Hello, class. This is now Astrophysics Lab 3 Makeup Part 2. So, Lab 3 Makeup Part 2. And we'll go ahead and slide down to here. And um, what we want to do now is we want to consider Carson City, where we live, and we want to examine some situations that occur in Carson City. So let's go back to our globe here. Previously, we were pretending that we were in England. But now what we want to do is, remember now, this is 0 degrees right here. So now what we want to do is we want to go here and go to Carson City. Let's go ahead and kind of turn this over here like so. And all right. So over here, here is Carson City over here. So let's go ahead and let's kind of see what's going on here. So from the prime meridian, Carson City is about 119 degrees west. Okay, there we go. Mm, okay, close enough. All right. So from here, this angle is about 119 degrees west of the prime meridian. Okay, and also we are 39 degrees north of the equator. So let's go ahead and let's kind of rotate this around as let's get Carson City in here. And there we go. All right, so we are 119 degrees west. Let's go ahead. We're 39 degrees north. Okay, that's close enough. All right, so we're off a little bit. So Carson City, we're 119 degrees west of the equator from the prime meridian, and we are 39.3 degrees north of the equator. All right, so that's important that we know the coordinates of Carson City. Okay, so now let's go ahead and click on this link here, and it gives us. Go and click on this here, and let's use this link right here, and it gives us longitude and latitude, local date and time, universal time, as well as local sidereal time. This would be important for our discussions today. But right now, let's go ahead and make this set for Carson City. So we need to know up here, we're 109. So let me go ahead and go up here, and let's backspace that. Just put in 119 degrees west. Okay, west. Okay, apply longitude. And as you can see here, we are minus 7 hours away from the prime meridian. Okay, or from universal time. That's because we have daylight savings time right now. When we fall back to standard time, we'll be -8. Okay. So right now in Carson City, it's Monday the 14th, September 2020, and it's 5:40 in the morning. Yes, I am awake at 5:40 in the morning, and Universal Time is now 12:40. 14. Now, take a look up here. See how it says run? Let's be like Thanos and let's go ahead and let's stop time. Okay, so we're stopping time right now because we don't want to uh, keep running here for purposes of this discussion here. So the local date and time here, so let's go ahead and let's kind of minimize this like this here. And let's go ahead and let's slide this over to the side here like so. And there we go. Make a little bit, okay, 80%, and we'll go over here. Okay, so we're in Carson City. Okay, that's our coordinates. Now the date here, let's go ahead and put in the date. It's, we'll go ahead and say 9 14 2020. Okay, the Pacific Daylight Time. Right now now we're going to write it like this. See over here how it's 5:40:22. Let's go ahead and write this notation over here. Let's write it as 5 hours, okay, a space, 5 hours. We're going to go 40 minutes and 22 seconds. Okay. Notice how we wrote it here. We have hours and then we have 40 minutes. One apostrophe means minutes, double apostrophe means seconds. So that's Pacific Daylight Time. Universal Time, which is England time. Okay, remember this is in England. It is 12:40:22. All right, so we're going to go 12 hours, right? And we'll go 40 minutes and 22 seconds. Okay, that's the local sidereal time. Excuse me, the universal time. And we'll go back over here and let's take a look at this for a minute. Um, so the longitude was 119 degrees west, right? Latitude is 39 degrees north. Okay, now here's the important part right here. It says local sidereal time. Okay, local sidereal time. Right now it is, now this is, so the local sidereal time means where you are at. We are in Carson City, so this is our local mean sidereal time. Now, for astronomy, you have to look this up. Either Google it, get an app called Sky App, or some kind of an app that tells you the sidereal time of where you are at. So right now, the sidereal time is 04 hours. Notice how I put a 04 there because you need a placeholder. 20 minutes, and here we have 11 seconds. 11 seconds. That's our local sidereal time. Now, here's how this all gets connected here. Okay, so let's grab a pen here. Okay, if I know the local sidereal time, right? Okay, like right here, if I know this local sidereal time, important thing here is this is the value or the coordinate or the value for my meridian. If I know this, I know my meridian. Okay. Now you might say, what's meridian? You might have forgotten about that. So let's go back over here. Take a look at this. Okay. What's the meridian? Okay. So the meridian, remember, was that imaginary line. So if I'm standing here, the meridian is that imaginary line that goes through my zenith and all the way to the north and south pole, like this in the night sky. So that's my meridian. Okay. So if I know local sidereal time, it is my meridian. More importantly, more importantly, okay, local sidereal time means it's my meridian. It's also right here, the right ascension of any star that's along my meridian. So here I know the local sidereal time, it's my meridian, and these are the values, these are the stars that might be on my meridian right here. So let's take a look here. Let me go ahead and minimize this here. So right now the sidereal time is 4:20, right? 4:20, 11. So let's take a quick look here and see, look at right ascension. So in the right ascension here, this will be the X and this will be the Y coordinates, okay, of the stars, of any stars. Let's take a quick look here. Here we go. Here is Aldebaran. Aldebaran has a right ascension of 4 hours and 36 minutes. This is 4 hours and 20 minutes. So Aldebaran, okay, let's go right here. Aldebaran will be right over our meridian. Okay, but okay, it's on our meridian. However, take a look at this right here. It says 16 minutes and 16 minutes and 31 minutes. Okay, now let's go back over here. Let's take a quick look over here. Our latitude is 39 degrees north. Okay, Aldebaran is 16 degrees north. So it'll be a little bit to the south of us as we look in the night sky, okay, because we're at 38 degrees. So what does that mean? So let's go back over here. Uh, so um, right now, let's go ahead and set this up here real quick here. Carson City. So right now the sidereal time is, let's say 4:20. So let's go ahead and let's kind of go over here and let's move this to 4. We want the sidereal time to be about 4:20. We'll just say 4 hours just to make it easy for ourselves. 4 hours. We'll go here. And so if we're in Carson, so here we go, is 4:20. Now the latitude was 16 degrees, right? 16 degrees. So here's, let's go 16 degrees. Okay. All right. So here we go. 16 degree. Okay. All right. So here is us right here. Here's our latitude right here. And here's our meridian. Okay. And see, see. Oh no, we want the, okay, this is our, okay, we're at 4 hours and our latitude is 39 degrees. Okay, this is us. This is us in Carson City right now. And this is the star. The star is going to be 4 hours and 16 minutes. Go here. All right, so here we go. So here's us and here's the star. It's almost right on our meridian, and it's just, because this, it's just directly almost over our heads. So we're right here. Take a look at the star if we can see this. Okay. All right. So, uh, where are we at? Oh, here we go. Okay. So this is us. This is 39 degrees north here. So let's go ahead and get some notation here. And we'll go here. Okay. So we'll go here. Hold on. We want to go over here. Okay, let's go ahead and write on this here. Oh, here we go. So this is 39 degrees north. The star is 16 degrees. However, it is along our meridian. Okay. All right. So we can use this to help identify stars if we know the local sidereal time, which means that it's on our meridian, and that's the right ascension of stars along this meridian, and we have to use the declination to figure out where it is up and down. Okay, that will conclude part 2.